Alright, in this first video we're going to look at how to price or find the price of a bond, the issue price. So determine the price of a $1 million bond issue under each of the following independent assumptions. Now in this case we're actually going to use the PV tables, and all of the PV factors on the PV tables are rounded to 5. So if you're using a calculator or Excel to calculate this, you're going to get a slightly different answer, and I'll show you what I mean by that. So let's start with this first bond. It's a 10-year annual interest. So in other words, it matures 10 years from this point. It pays interest annually, so once per year. Has a stated rate of 9% and an effective rate of 11%. So really, to find the price of a bond, we need to find two things and then add them together. So I say it's a three-step process. The first step is to find the present value of the face value of the bond, because that's one stream of cash flow from a bond. It pays the face value back at maturity. So we have to find the present value of that one-time lump sum payment. The second flow of cash on a bond is the interest payments. The interest payments are like annuities. They pay out over time. In this case, once a year we'll get an interest payment for 10 years. So that's an annuity. So what we need to use there is find the present value of the interest payment. So a little bit different. But once you have those two PVs, then you can find the actual issue price. So let's start with this first bond. It's 10-year annual 9 and 11. Now when calculating bond price, we need to know the number of periods that's going to be paid out and the interest rate per period. So now to find that, to find the number of periods, we find that it's a 10-year bond, so that's 10 years, and it pays interest once a year. So you're going to take the number of years, multiply it by how many interest payments it makes per year, and that'll give you the number of periods for interest calculation on a bond. So 10 times 1 gives us an N of 10. So 10 periods is what we need to know. Next, we need to know the interest rate. Now, interest rates for pricing a bond, again, is always based off of the effective rate. So the effective rate is 11%. Now, that's per year, so you're going to take that effective rate and you need to divide it by the number of payments per year. So in this case, it's 11 divided by 1, so it's simply a rate of 11%. So what we need to do then is go and find the PV factor. So the first part is to find the PV of the face value, or the PV of the FV is what I like to say. So to do that, we need to find the PV of a one-time lump sum payment. So to find that, we need the table called the present value of 1. So right here, I'll pull up the present value of 1 table. Now, we've already found our N. We said that the N is 10 because it's 10 times 1 payment per year. And then we need to find the interest. Now, this is 11%, so we're going to scroll over on our table. Sorry, I hope that doesn't make you dizzy. Over to our 11% point, because we said the I was 11. So when we do that, we get 0.35218. So that's our PV factor. So we're going to go back to our table here, and we're going to put that in, 0.35218. Then you're going to multiply that out. So you're simply going to take your $1 million face value, and you're going to multiply it by 0.35218. And that's going to give you, and this one's pretty easy to do since it's nice whole round number, 180. So that's sort of the present value of that face. In other words, if you invested $352,180 today for 10 years at 11%, you would have $1 million at the end of that period. And that's really what present value gives us. It doesn't tell us what that $1 million will buy, but it'll tell you how many of those $1 million you'll have, or how many dollars you'll have, excuse me. Now the next thing is to find the interest payment. Now really quick, to find the interest payment on a bond, you take the face value of the bond times the stated rate times time. That's our first formula we need to do. So on this bond, remember the face value is 1 million. You're going to multiply that 1 million by the stated rate. This is the only time really we use the stated rate on a bond, is to find the interest payment, the amount of cash it will physically pay every period, in this case every year. So now we don't have to worry about time in this case because it would be 12 over 12 because this is an annual interest payment. So really you just have to multiply that 1 million by that 9%. So when we do that, that gives us a payment of $90,000 per year. Now, Let's do the PV factor. Again, that 90,000 is every year, so that's multiple payments. So instead of using the PV of one lump sum payment, we need to go in and find the present value of an ordinary annuity. So again, I've got that table pulled up here. So the present value of annuity at the end of each period, that's the same thing as saying the present value of an ordinary annuity. Again, the N and the I is the same. So number of periods, the N is 10. And then the I is our interest rate, and we decided that that is 11, so we're going to go over to N10, I11, and we get 5.88923. So let's go back to our worksheet here, and we're going to put that in 88923. There we go. I'm not the best at typing that sometimes. And then we're going to multiply that by the 90,000. So when we do that, we get 530,030, and we're going to round to the whole dollar, so 031. Okay. Now, step 3 in that process is to simply add the two together. So we're going to take the 352,180 right here, the PV of the face value. We're going to add that to the PV of the interest. So we're going to say plus 530,031. And when we do that, that gives you 882,211. Now, stop and think about that for a moment. Does that price make sense? Well, absolutely. Remember, our competitors are paying 11%. We only pay out 9% every year. So what we have to do is we have to discount the price down in order to attract the investors to purchase our bond, because they want that 11% rate of return. So by bringing the price down to 882 plus paying them 9% over that 10-year period, effectively we're giving them the 11% return on their investment. All right, so now I want you to pause this video and try to do the second one. Then we'll come back together to go over it. All right. So hopefully you paused the video and worked on the second. So again, this one is very similar to the first. There's one main difference though. This pays semi-annual interest. So that means our N and our I are going to be slightly different. Well, what do I mean? Well, in bond 2, it's a 10-year bond semi-annual. So you're going to take your 10, you're going to multiply it by the 2 because it makes 2 payments per year. So this one would actually have an N, number of periods, of 20. Then we're going to go over and say, oh, wait a minute, we've got this 11% rate. Well, that's a per year rate, so then we need to divide that annual rate by the number of payments it makes in that year. So we're going to divide that by 2. So when we do that, we end up with an actual interest rate that we need to look up of 5.5. So for this bond, number 2, the second bond here, we're going to use an N of 20 and an effective rate of 5.5 per period. So again, the PV is the same. We're going to go over to our tables, and let's go ahead and start with the PV of 1. Now, instead of a 10 payment, we need 20 periods here. And then instead of that 11%, we're going to look up 5.5. So we're going to do 0.34273 is going to be our PV of 1. So go in and put that in. So 0.34273. Then again, when you multiply that together, you're going to get 342,730 for your bond price, or your, excuse me, not your bond price, correction, your present value of your face value there. So now, that brings us to the next step, and that's the present value of the interest. And again, you have to find the interest payments. Now, this one's going to be a little different. It's still face value times stated rate times time. But let's put that formula in here now. So in this case, our face value didn't change. It's still the 1 million. Whoops, sorry. And then we're going to multiply that by the stated rate of 9%, so 0.09. Now here's the catch. This is an annual bond, or a semi-annual bond, which means it pays twice a year. So that means that that interest is going to be split. So we're going to do 6 out of 12. Okay. So this one's a little different. So when you take that 90,000, you actually divide it in half. So that means every 6 months this bond would pay out 45,000. Notice per year it's the same amount, right? This is 90,000 a year. This is 45 twice a year. It's still the same amount because the stated rate is the same. It's just the timing of the payout. So our PV factor is going to be slightly different because we're getting our interest payments earlier in the period. So instead of having to wait till December, so to speak, we actually get a payment in June, then one in December, or something along those lines. So it does make a difference in the present value. So again, let's go over to our ordinary annuity, PV, at the end of the period. We're going to do the same thing. We're going to look up our 20 periods at 5.5%. And we end up with, let me write this down, 11.95038. So let's go back over to our Word document. We're going to put that in. 11.95038 is our PV factor. Again, if you do this on your calculator, you're going to get a slightly different answer simply because of rounding. Multiply that by 45,000. And in this case, we get 537,767 and 10 cents. And again, we're going to round to our whole, so 537,767. And again, we would have a little rounding issue there. That's perfectly fine for this calculation. It just gives you an idea of how to calculate bond pricing. We're going to multiply that, or excuse me, now we're going to add those two together. We're going to take the 342 and we'll add it to the 537. And when we do that, we get 880,497. So again, because of this semi-annual, notice the difference in the pricing. Okay, it did make a difference in our bond price because of the payment stream of the interest. All right, so now try to do 3, 4, and 5, and I'll go ahead and take a moment and get those filled in so that you can see the answer, but I don't believe we need to actually go through each one individually. I just want to give you the solution. So pause the video for a moment, try to do 3, 4, and 5 on your own, and then start playing again so you can find the answer. All right, so hopefully you paused the video and attempted to work those 3 on your own. But here's sort of the outcome of that. When you actually place that in, here's the PV factors and everything that you should have in the price. Now I do want to point out, notice this last one. Bond 5, the stated and the effective are the same. If that's the case, we issue the bond at $1 million. So 1 million. Now notice we're $1 off. That's simply because we've rounded the two PV factors. So let me just show you what rounding does there. So if we go in here, we've got our little bond calculation worksheet here in Excel. So let me pull this up. I've got two, well, if I can get it to work. Alright, so right there. So I've got two sheets here. One does the rounding and one doesn't. So notice in this case, it will round. So let's put in, again, let's go back to where our effective rate was the 9% for that 20 years. All right, and so we end up with, our 1,184,000 here. So if you look, that's your bond price. Now, if you did not round that, notice what we get. Slightly different. So if you use your calculator and you don't actually round those figures, you get a slightly different answer. So 1,184,015 versus 017. And that's only a $1 million bond. Of course, if you had a higher face value, you may have actually slightly different amount there. Now, what that brings me to mind, I think when I did this last one, number 5, I may have had the incorrect years in there. So it's 20 at 2, so let's put 11 in there. I did slightly have the incorrect, so hold on, let's fix that. I put it as a 10-year bond. In the end, the price is going to be the same, but you would have different PV factors on there. And instead of stopping and just re-recording this, let's put that in there. So notice it's 11,746, 16.046 would be your actual PV factors. What that does then is it's 999,997. Again, you're $3 off. Why is that? Well, that's simply because we're rounding the PV factors. So let's fix our table here. So we're going to do a little bit of moving around and let's fix that. And again, my apologies, I didn't catch that I had changed that. So that was a 20 year. So your PV factors should be for 20 years, not for 10. Notice I pulled the 10-year factors. So 0.11746. And then that brings the fifth one to 117,460. There we go. And then that would bring this, 55 stays the same. It would be 16.04612. And that brings our total here to 882. So this should tie more to what you had. Again, my apologies. and you have 999,997. Again, this should technically be an exact 1 million, because if we look over here, notice, if there's no rounding, it would price it out at a perfect $1 million price, which it should. But because of rounding, notice this PV is rounded to the fifth. If you truly went out, notice how the PV factor here actually goes beyond that fifth decimal. So if you use Excel formula, or if you use a true full calculation with the formula for PV factor, you would not have that rounding to the fifth decimal place issue, so you would get that perfect $1 million. So keep that in mind. All of these are slightly off because we're using the PV table. Alright, so I hope that helps a little bit, and again, my apologies that I pulled the 10-year rates there. The result in the end would be the same, because if the effective and the stated are the same, your bond price should equal your face, saving a little bit of rounding error there. All right. Have a great day.